Hello students, welcome to the class. Let us continue our discussion with the wave and sound. This is the next lecture, second lecture of wave and sound. Here basically I want to discuss with you the equation of plane progressive harmonic wave. I want to discuss with you the equation of plane progressive harmonic wave. Now in the equation of plane progressive harmonic wave, knowledge of simple harmonic motion is required. In that especially the phase is required. So first of all, as an introduction, what I mean to say here, that here you see I have written two equations. One equation this is, and one equation this is. Here y is the function of t, and here y is the function of t and x. See, two equations are there. Out of two equations, you know that this is the equation of SHM and this is the equation of wave. I want to basically describe first this equation, the SHM equation, and second the wave equation. You are finding some similarity is there. Here this term is representing the phase, here this term is representing the phase. In fact, when we are talking about the wave equation, I will explain each term. When I will talking about the wave equation, in wave equation, two variables are there. One is t and one is x. That means the phase of this equation depends upon time also, and x means position also, distance also. Suppose here is the wave, here is the wave, here the particle is doing simple harmonic motion, particle is doing simple harmonic motion. When the particle is doing simple harmonic motion about its mean position, this is transferring its motion to other particle, this is transferring its motion to other particle, this is transferring its motion to other particle, and like that the wave is proceeding. What you have to understand in a comfortable way, that you see here the value of x is equals to 0. Here it can be x1, here it can be x2, here it can be x3. So there are two factors in which the displacement of particle, this is displacement of particle, here also it is displacement of particle, but this is displacement of a single particle along y-axis, and in SHM we have read about x-axis, that the particle has started from here, it has gone here and then again here. So this way we have discussed the SHM. This is x, and the same matter is repeated, only x is represented by y. So displacement y represents displacement, and x is equals to a sine omega t plus phi naught. This represents the displacement of particle along x-axis, and this is representing the particle of along y-axis. What I mean to say here, carefully listen, that for every x, the y is different. You see, for this x, the y is this much, for this x, the y is this much, and for the, so not only time is the factor, but it is the distance also that is the factor in responsible for finding the value of y, that is the displacement. So in wave there are infinite particles doing simple harmonic motion. So this is the wave equation and this is the simple harmonic equation. What I mean to say, that in wave a represents the maximum value of y. Here also a represents the maximum value of y, and that we call as amplitude. So a is your amplitude. Omega you already understand, it is angular frequency, and this term which is argument of sine function, or we can take cos also, that is representing the phase. Basically I want to discuss about the phase, because in the discussion of equation of wave we need the concept and understanding of phase. So first of all, as a prerequisite for the wave, I will discuss the phase of SHM, and then I will come to the equation of wave. Here in the equation of wave, A represents amplitude, here angular frequency T times, which is changing with C. T and T is different. This T is variable and this T is constant. This is time period. This is constant for a periodic motion and this is the time which is variable. Here x distance from origin and here distance from origin along this axis, and y represents the displacement. Y represents the displacement. Here this value represents the x from origin. Because it is on x-axis. If you will take on y-axis, it will represent the y1, y2 like this. Second thing is there k. K is your omega by v, that is 2 pi by t into lambda. This is v. So 2 pi by t into v, 2 pi by t is omega and t into v is lambda. So 2 pi by lambda is k, and k is your basically the propagation constant. K is the propagation constant. So this is your wave equation and this is your simple harmonic. Here this is your initial phase. Now I would like to make you understand the meaning of phase. So this was the basic introduction which I had discussed with you in order to make you understand what is wave and how wave and simple harmonic. So simple harmonic motion phase concept is essential for your understanding of 3-4 chapters. First for wave, second for wave optics, third for AC, and you should always keep this thing in mind. If you are comfortable, and sound also, if you are comfortable in understanding the simple harmonic motion, these 4-5 chapters will be, you will feel very highly comfortable. This is mean position. Here is the amplitude. Here is the amplitude minus plus, and particle has started in this way. In this situation, as I told you, the equation of simple harmonic motion, as it is along x-axis, the displacement, suppose it can be here also, this value can be x or this value can be x, and maximum this value can be x. These are representing the values of x. So x1, x2, x3, and x1 is the maximum, and when in maximum it becomes to the positive side, it becomes your A. This thing you should understand from the simple harmonic motion. So particle is doing simple harmonic motion. Now this is treated as origin, this direction is treated as positive, and this direction is treated as negative. What I mean to say you that here you basically I want to discuss phase. So first I will discuss x is equals to A sine omega t plus phi naught. I will explain the meaning. So what I mean to say that here x is equals to A sine omega t plus phi naught, because I am taking x-axis, so I have taken x. If I will take y-axis, I will take y. So in understanding the wave, we have to deal with infinite SHM, and this is the SHM of a single particle. This single particle is performing to and fro motion about its mean position, where the F net is 0. F net is 0, mean position, and this mean position, if you see, this is the position of the particle, and if you want to find the velocity, v is equals to dx by dt, and then in this situation a omega cos omega t plus phi naught. This is the velocity. Now this argument of sine or cosine, so again I am writing, I have already written, but I am writing argument. What is argument? Argument is this term inside the bracket. This argument is your phase, and this phi naught is called initial phase. Name, only you remember the name, then I will explain the meaning. Now the question arises, phase is what? Phase represents which quantity? Meaning of phase is not clear to the student, and then he has the problem in wave optics also, in sound also, in AC also. So first, clarity of concept is required. Phase gives complete information. It tells state. It tells state. And this state includes position also, and velocity also. Velocity also. For example, if I mention only position, then that is not the complete information. So this is basically the complete information. State means complete information. Complete information. State means complete information. Now, basically, what I mean to say, you people, in the discussion of phase, if I am saying that here is the simple harmonic motion, if the at time of is equals to 0, the particle has started from here. Now this gives the position x is equals to 0, but it is not telling about the velocity. You understand that the velocity here is maximum, but it is not telling that this direction or this direction. And if I mention the phase, this thing will be also known to you and this thing will be also known to you. If I mention the phase. So x is equals to a sine omega t plus phi naught. This term is your phase. See how I am trying to make you understand. If I write x is equals to a sine phi, then velocity v will be a omega cos phi, because this will be remaining same. V is the velocity. Now you see, this phase phi in the wave equation, here is the wave, here you are taking 0, here you are taking pi by 2, here you are taking 3 pi by, here you are taking pi, here you are taking 3 pi by 2, and here you are taking 2 pi. Basically, what does it mean? Phase is 0, phase is pi by 2, phase is pi, 3 pi by 2 or 2 pi. What does it mean? What is the physical significance of this phase? That I want to clarify you people. Now see, if phi is equals to 0, that means in this equation, try to understand, x is equals to 0 and v is equals to a omega, and this is positive. What does it mean? It means that in the simple harmonic motion, here is the x0 and v is the positive, that means particle has started in this way. T is equals to, the particle motion has started in this way. This is the meaning of phi is equals to 0. Phi is equals to 0 means this thing. Now take, suppose phi is equals to pi by 2. If phi is equals to pi by 2, then you see x is equals to a, x is equals to a, sine phi, sine pi by 2 is 1, so a, and v is equals to 0, cos pi by 2 is 0, so v is equals to 0. Here a is positive. What does it mean? It means that we are observing the motion from here. So this is plus a and this is x is equals to 0 and t is equals to 0. So particle has started its motion. Phi phase is equals to pi by 2. It means particle has started motion from this point, and here the velocity is 0. So if the particle is starting from here, the phase is 0. If the particle is starting from here, the phase is pi by 2. So you can understand this thing also. If we keep here pi by 2, then it will be x is equals to a cos omega t. So whether it is x is equals to a cos omega t or a sin omega t, both represent simple harmonic motion. But if the motion starts from here, we will write the equation x is equals to a cos omega t. This thing should be clearly kept into mind. So first situation is this, second situation is this, third situation we can take phi is equals to pi. If we take phi is equal to pi, what does it mean? Phi is equals to pi means x is equals to a sin pi. Sin pi is how much? It is 0. It is 0. And v is how much? A omega cos pi. That cos pi is -1. So minus a omega. This is negative. What does it mean? It means that particle is starting from here at t is equals to 0, x is equals to 0 and v is negative. That means in this direction the v is there. This is negative. Minus a plus a. This is the meaning of phi is equals to pi. If you take some other value, then also you can get in the same manner. You can test it for 3 pi by 2 and you can test it for 2 pi. That means I have tried to discuss when the particle start motions from here, here in this direction, here velocity 0, here in this direction, then for here velocity will be 0 and then for here in this direction. So in this way, it is not essential that particles should always start from here, the simple harmonic motion. It can start from here also, here also, here also, anywhere it can start, and it can start in this direction also and in this direction also. I will further clarify the concept of phase to you people. So you should understand that phase gives you this quantity, position, and this quantity, velocity. So velocity with sign, that means whether the particle is going in this direction or whether the particle is going in this direction. This is basically your phase. Phase has this meaning which tells the state, which gives the complete information of position and velocity. What is the position and what is the velocity? Condition that it will explain in a comfortable way. This much information of phase must be with you. Now you will ask how it is useful in wave. That also I will tell you and I will give you. We must know how to calculate initial phase, because here you see equation this was the equation of SHM as I told you, and x or y, as we will be dealing with wave in y direction, so I am writing this will be your equation of some similarity you are observing. Some similarity is there, that the nature remains the same, only the two variable is there. As I told you earlier, this is the function of time only. Time changes, it changes, and here it is the function of t comma x. Both quantity are there. Now in equation of wave, if we want to equation of wave, this is basically a equation of wave that is moving, progressive wave moving in this direction. This is the equation of wave that moving, and it tells about this is your plus amplitude and this is your minus amplitude. It between the particle, infinite number of particles are doing simple harmonic motion. What I mean to say here, it is not essential that it should start from here. It may start from here. You see, in this way the wave is starting. Then at t is equals to 0. Then what will be the equation? Here what will be the equation? Or we can say the situation, if suppose this is a, it is taking here in this way. This is suppose some value a by root 2. Then what will be the equation? So these equations you can find if you have the understanding of this concept, that is initial phase you are knowing. This initial phase you are knowing, then only you will be able in giving the equation of such equations. So equation of such a plane progressive harmonic wave. So what I mean to say, now I will make you understand in SHM how we calculate the phase. Because if we are calculating the phase here also we will be getting the phase. This is the equation which has started from here. If we can take, we can replace it by this way: a sine omega t minus kx plus phi naught. You see, in this way. So you, for complete understanding of wave, what is required, this initial phase knowledge and information must be with you. So we should know how to calculate this one. This is basically the part of SHM, but here we will require this thing. So I am a little bit trying to discuss this thing also with you people. I am trying to calculate initial phase. X is equals to a sine omega t plus phi naught. This complete is your phi phase, and this is your initial phase. My main intention is to calculate initial phase is equals to how much, because it will be very useful for you in finding the equation of plane progressive harmonic wave, and after discussion I will start the derivation of plane progressive harmonic wave. Now in this situation, first of all you have to take the axis. See here I am taking x, here I am taking x dash, here I am taking v, here I am taking v dash. If the first quadrant is there, both is positive. Here it is x, that is negative, and velocity is positive. Here both negative, and here x is positive and v is negative. This thing you have to remember. This. Why I am discussing this? Because I want to tell you how to calculate the initial phase, and this information will be very useful to you if you are able to understand this concept. This is basically a short trick. This is a basic short trick one by which you can immediately and correctly calculate the initial phase. So here v is also positive, x is also positive. Here v is positive, x is negative, v is negative, x is negative. Here v is negative, v is negative. Here x is positive and v is negative. V is negative, plus minus, v is negative. This thing you have to always keep in mind, and then you will have to draw a circle. And in this circle you will take this will. Here it will be plus a, here it will be minus a, and your sense of rotation will be clockwise. For every position on the axis, distance we are measuring from mean position. Here this will be your mean position, origin, and this side plus a and this side minus a. When you will draw the circle, then you will start the uniform circular motion in clockwise sense, and you will try to feel that what is the position of particle for every position on the uniform circular motion. And also you should understand that this distance, radius, is basically your amplitude. This amplitude is radius of this uniform circular motion. If you have understood this concept and this concept, you can comfortably find the initial phase. For example, here you see that this is plus a, this is minus A, and the particle has started from here, x is equals to 0, t is equals to 0 in this direction. Velocity is in this direction. Now you see, and you have to find, this is the first example I am taking, and you have to find what is the phase. Phi naught is equals to how much? That means equation of simple harmonic motion will remain same. Amplitude is A and omega is angular frequency is same. Phi naught, if we are able to find, we will find the equation of simple harmonic motion. So in this situation, here you see, you will start from here. Now you will start from here. When you are starting from here, x is equals to 0 because this value is representing the x whose maximum value is, you are starting from here, so x is equals to 0, and velocity has this direction. This direction means velocity is in this direction. In this direction you are moving. Now you are getting the two position. One is here and one is here. For every value of x you will be getting the two position. Suppose here the value of x is 0. Here the value of, suppose x is equals to a by 2. Here also you are getting the two position. Suppose here some other value of x is there, then also you will be getting two position. Here some value of x is there, you will be getting the two position. You see, for every value of x you will be getting the two position as I am showing you in the diagram. Now here the value of x is 0, that means one position is here, x is 0 here, x is 0 here, so one position is here and one position is here. But what you have observed, velocity is towards plus a, that means velocity is in this direction. So this is the correct situation, and in this situation this line makes with this how much? 0 angle. You will see, if the position is here, this will give you the phase. If the position is here, this will give you the initial phase. If the position is here, this will give you the phase. Like that only. This complete quantity will represent this quantity. So my main intention is there to find the initial phase. So here is the, so what you are getting the phase in this situation when x is equals to 0 and t is equals to 0, you are getting the phase, that is phi naught is equals to 0. Why? This angle is making 0. So when it is 0, then what will be the equation? Equation of simple harmonic motion. Equation of simple harmonic motion will be x is equals to a sine omega t. So if this is the equation of simple harmonic motion, you should understand this thing, that the particle is moving, particle is starting its journey from x is equals to 0, and at the same time it is moving towards the positive x direction. If you will say, no sir, I want that the particle is going in this direction, then what will happen? Then particle is going in this direction, that means it is in negative direction, so it will be this position, because in this way you see, here you will be getting the negative value of x. So here you will be getting the negative value of x, and what will be the angle? Angle will be your this angle, because this will be the position of particle. So this will be your how much? Pi. So you will write that x is equals to a sine omega t plus pi. This will be representing the value. This will be representing the particle if the particle is moving in this direction. But two direction I have mentioned. From the mean position I have mentioned one this direction, and from mean position I have mentioned one this direction. If I am mentioning this direction, this is the position of particle. If I am mentioning this direction, this is the position of particle. So this, for every value of x you will get two value of position, two positions you will get. So this will help you in getting the initial phase, and you will be in a comfortable state of finding the phase, and that will help you in writing the equation. Why I have discussed this equation for you? Because I want to discuss this equation which I will be using in the equation of plane progressive harmonic wave. So in the harmonic wave I will be using the same equation. Now try to understand that I am giving you in the simple harmonic motion, I have taken one x is equals to 0, and particle is moving in this direction and particle is moving in this direction. This we have already made the discussion. This thing we have already made the discussion. If suppose here the x value is a by 2 and the particle is moving towards this direction, that is plus a, here it is minus a, then what will be the value of initial phase and how you will calculate? This is at t is equals to 0. That means you are observing from this point where the value of x is your a by 2. In this situation, how will you find the phase? In this situation, how will you find the phase? Here you try to understand. As I told you, I will be taking a circle. I will be taking in this way. Here the x value is 0. Here the x value is a by 2. X is equals to a by 2. As I told you, I will take a vertical line. 2 points we are getting. 1 point is this and 1 point is this. This is the amplitude that we are taking, amplitude of SHM, and this value will give you, now out of this 2 position, what will be our answer? What will be, which position is correct? Whether this position or this position, because at x is equals to 2 by 2, 2 positions are possible. One position is this and one position is this. As it is moving towards positive A, so if the sense of rotation you are taking this way, in this way it is moving towards the positive A plus A, this is your minus A, it will be going in this direction. So this is our correct position. Now we have to find this value. This is your phi naught. So this will be your phi naught. And this distance is how much? A by 2. So if I take this angle is how much? This angle, suppose I am taking as theta. So for this angle, this is your A. What we have to find? We have to find this angle theta. So if I want to find this angle theta, we can take for this angle cos theta is equals to this distance A by 2 by hypotenuse, this is base and this is hypotenuse, by A, that is 1 by 2, that means cos 60 degree, that means cos pi by 3. So theta is equals to pi by 3. This theta is pi by 3. So this will be how much? Cos theta is pi by 3 and this complete is 90. So this is your, that means this is your 60 degree. So this will be 30 degree. So this phi naught will be your pi by 2 minus pi by 3, that is giving you 6 pi by 6. So phi naught you are getting pi by 6. So what will be the equation? Equation will be x or y. X is equals to a sine omega t plus pi by 6. This is the equation 1. When the particle is at this position and it is moving in this direction. Now the same thing I am giving you, at this position the particle is going in this direction. Then what will be the answer? You can understand that in this situation the answer will be, now this is not the position, now the answer will be in this direction. This will be your answer. Why? Because here you see, here what you are getting, here you are getting, this will be the position, because it is velocity direction will be how much? Velocity direction is negative, and in this what I have said, velocity is negative and x is positive. So in this direction, so this is the position. So if second situation, same situation is there, here at x is equals to a by 2 is there, t is equals to 0 and particle is moving in this direction, then this position will be there. And when this position will be there, this angle you have to take. And what is this angle? This angle is basically, I would like to tell you, here you see, Here you see this is a by 2. Here is the position of particle. This is your pi by 2, and here this angle, suppose theta, so cos theta base a by 2 by hypotenuse a. So what we are getting? We are getting cos theta is equals to pi by 60 degree. 60 degree is how much? Pi by 3. 180 by 3 is 60. So pi by 3 cos pi by 3. So theta is your pi by 3. Now when theta is pi by 3, you want this complete angle. So for complete angle, what you will have to take? You will have to take, this is your pi by 2, this portion is your pi by 2, and this is your pi by 3. So what we are getting? We are getting in this way that this is pi by 2 plus pi by 3, and that is giving you 6. 3 plus 2 pi, that is 5 pi by 6. So if the particle is moving in this direction at t is equals to 0, then what will be the equation? Here the equation will be x is equals to a sine omega t plus 5 pi by 6. Try to understand. See, position remains the same. That is a by 2. But one time the particle is going in towards positive way, and one time the particle is going towards negative way. That means velocity, here the velocity is positive, here the velocity is negative. And what you are getting? You are getting the equation changes. Here the equation is omega t plus pi by 2, and here the equation is omega t plus 5 pi by 6. This concept I had discussed. So this way we calculate the initial phase. Initial phase we calculate in this way. So this concept is essential because in the discussion of wave, sometime I will start the wave in this way. Sometime I will start the wave in this way. Now this is your, if this is your a by 2, this value of pi by 2, you will have to take this value of pi by 2 or this or this. Whether you have to understand the particle is going towards the mean position or away from the mean position. So this is your mean position. Here it is your mean position, it is going towards the mean position. Here it is going away from the mean position. Here it is going towards the mean position. So therefore, this concept is essential. Hope that this many more discussions can be done on this one, but I have not done it. Why? In the wave I will be discussing. So my request is there that you should understand the simple harmonic motion in a very comfortable way. And then I will, in the next class, I will discuss your equation of plane progressive harmonic wave, and different equations I will find with different phase I will find, and this concept is essential for understanding that I will be discussing in a better way. So hope you have enjoyed it. Thank you. Have a nice day.